Cool. Hi guys, Fridays with Daren. My name is Dane Myers, and I wanted to just spend a minute talking with you today about Powerwall. Daren is on his way up to the roof. Today's episode, we're gonna focus on installation and how exactly it works putting panels on your roof. So Daren is making his way up to where his panels are located. I know a lot of people are very interested and passionate about Tesla Powerwall. As you probably know, Goldin Solar is a Powerwall installer, and coming up into hurricane season is always the busiest time for us related to Powerwall. So I wanted to take a second and I'm going to share my screen with you. And the first thing that I want to address is why Powerwall? So the first thing that comes up, people are looking for ways to back up their home. They may be interested in Powerwall versus a generator. And the number one thing that people are looking for, obviously, when they back up their home is, are we going to have an outage? Like, what do I need to do to make sure that my family has power, basically, no matter what? And there's a few limitations when it comes to a generator. Number one is you have to have fuel for your generator. So by nature, we don't know what's going to happen when we have, a disaster like a hurricane. And so it's difficult to make sure that you have enough fuel. And that's something that, we regularly experience when there's a hurricane, that there's a line to try to get gas and to make sure that everybody feels prepared for what they need. But with a Powerwall, you don't have to worry about that. And if you have solar, assuming that you have solar, then your Powerwall is going to be able to recharge from the sun on a regular basis. And that's really important because you know that as long as the sun is coming up each day, then your Powerwall is going to be filling up with energy, and you're going to have what you need for the nighttime. And during the day, you're going to be able to draw that power right off of your roof. So assuming that your system is sized correctly, your solar panels, or you have the right number of solar panels, then you should be able to conceivably run your home from battery backup on a regular basis during the event of an outage. And so what comes up frequently, the next question is, how many Powerwalls do I need? I'm going to share my screen here and show you a graphic. Oh, looks like we have Daren back with us here. Daren, how's it going?
Going amazingly well. Thank you very much for asking. How you doing today, Dane?
Doing great. We were just touching base about Powerwalls a little bit, and but I understand that you're going to be taking the jaunt up to your roof to show us your installation up top.
That's right. Yep. Going to be climbing up to the roof. Going to check out the solar installation. There we're going to see the solar panels. We can see the DC power optimizers. We can show the racking. This is something that I love talking about. And I think racking is one of those subjects that doesn't get nearly as much attention and discussion as it deserves. People just say, well, it's not the sexy part of the solar system. It's not the panels, it's not the inverter, but it's no less important, and we live in Florida and we have hurricanes. We have to design for hurricane wind speeds, 175 miles per hour. Not every type of rail can actually, successfully do that. So, we know that we're using one of the strongest rails in the industry, and I'm looking forward to showing it off.
Yeah, can you just briefly describe what racking, what all that entails? I mean, maybe it's different for different roof types, but what is racking exactly?
Definitely. So racking is the structural system that holds all the parts together on the roof. So basically, we've got solar panels that convert sunlight to direct current. We've got an inverter that changes direct current to alternating current. The racking is the skeleton of the system that holds it all together. And so typically we run rails, and we like to run the rails perpendicular to the rafters, right? And then we penetrate the roof. We fasten the rails to the rafters with standoffs, stanchions, structural attachments. They have many names, but they're structurally attached to the existing structure. We're not just attacking them to the deck. We're structurally attaching it to the existing structure. And then from there we have rails, and then we put the panels on the rails, and then we connect the panels electrically. So it sounds pretty straightforward, but there's actually a lot of technology that goes into the rails in terms of its structural strength. What kind of alloy is it? What kind of gauge is it? What's the geometry of the profile? And then believe it or not, the racking actually plays an important electrical part in the system, and that is that the racking has to be able to ground any surge current. So the racking is made out of metal, they're typically aluminum rails. And so if lightning strikes the rail, or if a piece of solar wire has an insulation that gets worn off, and you've got exposed copper, and we have current running through that copper, and it touches that rail, there has to be a safe pathway for that current to travel to the ground. And so nowadays, racking has to be equipped with, has to meet a UL standard called 2703. And that is that every single component in the racking system, which are the clamps, the standoffs, the splice bars, the rails, the end clamps, the mid clamps, every single part of the racking system has little serrated teeth that pierce the epoxy coating on the rail and allow something called bonding, which means that electrically they are conductive. And so if any electricity went to any of the metallic pieces, they have a safe way to travel to the ground. So another one of those examples of very important considerations that we have to keep in mind when we talk about the racking, which usually gets very little attention.
That's cool, and I think it'll really come to life when we go up on the roof and look at it. But it sounds like what you're saying is that all of the pieces of the system that are designed to mount the panels on the roof are all specifically designed at a very detailed level. Are the building departments familiar with the ratings for these pieces of equipment, or how is that made accessible to whoever is reviewing the system to make sure that it's going to withstand like South Florida wind speeds and things like that? It's like,
so when we do the structural aspect of the design, there's a lot of boxes that need to be checked, so to speak. There's a lot of different areas that we have to look at. As the saying goes, a chain is as strong as the weakest link.
Yeah.
Right? You can think about a structural system as being similar to a chain. So for example, you have the wind trying to suck the glass out of the panel frame, right? So the first weak point is, what's the strength of the glass itself? The glass has to be sure to not shatter in those wind speeds. And then assuming that your glass is strong enough, the next question is, how strong are the sides of that aluminum frame, the solar panel frame, at gripping on to the glass of the panel?
Mm-hmm.
Is that strong enough? And then the next question is, how strong are the mid clamps that hold that panel frame onto the rail? See, and then the next question is, how strong is the rail attached to the standoff? And then the next question is, how strong is the standoff attached to the roof? And so you see it all the way from the glass, that is the thing interfacing with the wind, all the way down to the lag bolts or tapcons embedded in either the wooden rafters or the concrete slab, respectively, depending on the roof type.
Mm-hmm.
So you're going all the way from, where that wind first interfaces, all the way to the existing structure that we're anchoring in. And really, I go back to that chain analogy. You have to make sure that every link in that chain is strong enough to meet, to meet the loads.
Right.
Which in South Florida, that means 175 miles per hour wind speeds.
Yeah. Well, you by trade, you're a structural engineer by education and experience, right?
Yeah. So I got my bachelor's in structural engineering, which is really civil engineering with a specialization in structural, because civil is kind of a broad term that encompasses geotechnical engineering, transportation engineering, structural engineering, and so on and so forth. Structural, water resources. Structural was what really fascinated me, but then I decided, I didn't really want to be kind of hidden away working at spreadsheets, sizing concrete beams, sizing, structural members, I-beams, and channels. I wanted to be on the job site, so I actually got my master's in construction management, and ended up working as a project manager and as a superintendent, managing construction job site organizations. So I've always loved to be on the construction job site and to get really involved with the project itself. But I do have years of education about structural engineering, and then when I got into solar, it kind of came full loop, and now we're looking at exactly those types of problems. And this is something that if you're not in Florida, chances are you really spend very little time thinking about.
Right.
There's a really wide variety of structural components that are used specifically in the solar industry. So for example, the thing that connects the racking to the roof can be an L bracket, which is shaped like the letter L. And that L bracket would have, one lag bolt going all the way through it. So for example, this is an L bracket. This would be the lag, and it's sort of going through it like that, connecting to the rafters. Well, this probably works in just about everywhere but Florida, because this represents one single attachment. See that? The other thing is that where the rail is connected is up here. This is where the rail would be connected. And so if you've got a rail connected up here and you've got a lag bolt going through there, it's creating a rotational tendency because of the way that it's loaded. It's attached. It's not axial. It's not in the same direction of the attachment. But if you're in Florida, we're going to put down a rectangular bracket shaped like a rectangle, and then it's going to have two lags grabbing it from either end. And then right in the center, there's going to be a cylindrical post. So number one, you're attaching with two lag bolts instead of one. So you've got double the attachment. Number two, the axial direction of the pull is is on a standoff right in the middle. And then it's got two lag bolts on either side. So it's symmetric. It's not creating a rotational tendency, like a lever arm. That's what's known as a bending moment in structural engineering. So, that's just one example. That's just the attachment.
Yeah.
Then
and it sounds
the
like
gauge of the rail.
I was gonna say, it sounds like there's a wide variety of hardware options on the market. And, obviously a lot of places around the country are not going to have the kind of demands that South Florida has. So, I think you were born in Miami, and being from Miami, being familiar with the realities of hurricanes and how scary it can get. And I mean, just like the data side of it and the engineering requirements of it as well. This is kind of a unique environment to design solar for, if I'm correct. And
For sure.
Getting the building to permits down here are probably harder than anywhere to get. But even so, I think it's peace of mind knowing that if I were to get a solar system installed from Goldin, that this is someone who is very aware and knowledgeable of the climate, no pun intended.
Yeah. And you can definitely count on that. And there's really two aspects to that. The first aspect is, like you mentioned, my background structural engineering. So there's certain things that, and I'm from Miami. And so there's certain things that I really won't take lightly. I've bid for a project, and the homeowner showed me some proposed means and methods that another company that they talked to proposed using. And essentially they wanted to take like a big plastic block, put some adhesive foam on the bottom, and just slap it down on the roof, and then attach the panel to that. And I just looked at it, and I said, you have to be crazy if you think that you're going to attach a solar array to a roof with blocks that are simply foamed on without actually having mechanical fastening to a structural member. And again, the manufacturer of that methodology, that might be fine. That might be totally okay in 49 other states. But where we have 175 miles per hour wind speeds to contend with, that is a terrible idea. I mean, the one thing that people need to understand about solar panels and structural design, people say, hey, isn't that going to be a lot of weight on my roof? The answer is it's a lot of weight, but it's very little pressure in terms of downward force, because pressure is force divided by area, right? So pressure is where you take a certain amount of weight and then you divide it by the area of that force, and that's what gives you pressure. Okay. Solar panels are 80 pounds on a 40 square foot panel. Okay, if you do the math, that's approximately 2 pounds per square foot. So if you think about something that's about a square foot in size, about a square about that big, that's about a square foot. If you put 2 pounds on that, that's nothing, right? I can stand on a roof and I'm 200 pounds, and I can put my feet together and I'll be 200 pounds on a square foot. So a solar panel pressure equals to 2 pounds per square foot. So again, the weight of the solar panel is not a problem at all. But that light weight on the solar panel is actually the double-edged sword, because what a solar panel ends up imposing on a roof isn't downward forces that are challenging, it's upward forces that are challenging. I mean, one of the things that characterizes kites is that they're very, very, very lightweight and they have a large surface area, right? Just like an airplane wing, it has a large surface area and it's relatively lightweight. And so the idea is when you have something light, that's a lot of area for the wind to pick up. And so, you know, the challenge with solar panels in Florida is never the weight that they're pushing downwards, but it's the wind wanting to pull them up. And that's where we look at, are the anchors that are used to secure the system to the roof strong enough to do that? Is the rail strong enough? Are the clamps holding down the panel frame strong enough? Is the panel frame itself strong enough to hold onto the glass? And is the glass strong enough to not just shatter when the wind wants to yank it out?
Yeah. Can we see some of the things you're talking about? If you go up on the roof, can you show us some of the stuff?
Absolutely. Yeah. So I'm going to go to my roof and I'm going to climb up there and show it to you guys.
Right on. I'll in the meantime, I'll continue my Powerwall commercial here. Let me share my screen here and show you guys what I was talking about. Just a second. All right, cool. I'm going to assume that y'all are able to see that. So we were just talking about hurricanes and making sure that the roof is ready to withstand, you know, what happens during a hurricane. But one of the questions we have when people are interested in whole home backup is how many Powerwalls do I need to get? And so this is a graphic that we designed to help people understand the way that we size the number of Powerwalls for your home based on your usage. And there are two things that really need to be taken into account in this decision-making process. And that is the amount of energy that you need to be able to store so that you have enough water in the jug, so to speak, to get you through the night to the next day that you're going to get solar. And then the other factor is how many appliances you're going to want to run at the same time. Oh, it looks like Daren's back up on the roof now. That was a lot quicker than I thought. We're going to get back to this Powerwall discussion, but Daren's back up on the roof now, so we're going to turn it over to him to show us some of the things that he was talking about. Can you hear me, Daren?
I can hear you. Yep. Can you hear me?
Yeah, absolutely. This is fun.
Sounds good. You want to change over the video to me?
Yeah, absolutely. Here, I'm going to stop sharing. Great.
Cool.
Got it.
All right, so here I am. So I'm up on my rooftop. Here's my solar array. Pretty sweet, huh?
Yeah, very awesome.
Basically, I got the whole roof just about covered here. And these solar panels are not, you know, electromagnetically levitating above the roof, right? They're structurally attached to it. And so there's a whole system that thinking about, you know, the panels in here. But again, this is a component that's no less important, but very often overlooked. So I'm going to show you guys a couple of parts about it. So right
Cool.
here.
So this is the
and
rail.
This is the snap. This is the snap and rack rail. You can see here that there's a channel on the top and there's a channel on the side. So the channel on the top connects the panel to the rail. And you see right there, see that? And the clamp is connecting the end of the panel to the rail through the top. And then this is the side channel. Right? And what this is doing is attaching the rail to the stand. And so you got that 1-inch diameter cylindrical post. And so this attachment right here, standoff clamp, because what this is the clamp that attaches the rail to the standoff. Clamp. And the way that it works is it's sort of like a collar, you know, works its way around the 1-inch diameter standoff. And then as we tighten in the channel nut, which is that right there, it's sitting in the channel and it's like a nut. As we tighten it, the collar starts to pinch around the standoff, and that's what gives it that uplift strength. So then we've got this rubber collar right here. This is just like a drip guard, but I can peel it up and we can see what's going on underneath it. Basically, this cone right here is the flashing. This happens to be a TPO flashing. And so what you don't see under here is the bracket that is structurally fastened to the rafters of the roof. And so, you know, we got the top of the cone wrapping around the standoff clamp with a hose clamp, then it's silicones. And then on top of that, I just keep that drip guard just to keep it away. And yeah, this roof has never leaked. I mean, this has been a really good, you know, waterproofing roof. One of the things that we have to do is locate the rafters, because we're not just trying to attach to the deck. We're trying to attach to the actual rafters. And you know, the standard is that rafters are 24 inches on center. And so really, once you find one, you just kind of measure them off and you know where they all are. But you know, you can see the number of stands that we have here. One of the things that I did on my roof that was really cool is 18-inch standoffs. So we get 18-inch standoffs from Snap and Rack. That's one of the sizes. And the reason that I did that is twofold. I have a 18-inch parapet wall going all the way down, all the way down the roof here. And so there's two things. I don't want to, you know, see the panels from the ground if I can avoid that. And also, I don't want the parapet wall to shade on the panels. I want the panels to get the maximum sun exposure. And so I also want to be able to utilize as much of my roof as possible to put solar panels on. And so what I did is I actually matched the height of the standoffs to the height of the parapet wall. They're both 18 inches. And what that means is that I can take the panels as close to the edge as I need to. And number one, you know, just to give you some sense of matching of the heights, number one, this parapet wall never shades on the panels. And number two, you know, it's still not visible from the ground. So, you know, to anybody that's developing, anybody that's building a building, you know, I strongly recommend like an 18-inch parapet wall, because that'll help hide the panels. We have some super high-end customers that we're talking to, building, you know, super big houses, 8,000, 12,000 square foot homes, and they're flat roofs. You know, that's sort of the direction the world's going in these days, is modern flat roofs, and they're, you know, they're saying, hey, I don't want to see the panels from the ground. And so one way to avoid it is having a parapet wall with matching height stands, and that way the whole system just kind of blends in.
Got it. Can you talk a little bit? You mentioned about going into the rafter versus the decking. Can you just give, like, for the layperson, a brief overview of like the parts of a roof and what the difference is, how important it is to go in the rafter versus the decking?
Right. So the deck is just plywood. We're talking about really thin plywood. I don't know, like half an inch usually, right? 3/4 of an inch, maybe less, maybe a 1/4 inch. Plywood is not thick, right? The purpose of plywood is to create a plane, is to create a horizontal surface. On the other hand, the rafter is the structure underneath the plywood deck. So the rafter is like the 2x4, the 2x6 that runs all the way across from one end of the roof to the other. And so this roof has 2x4s running like this. Every 24 inches, there's a 2x4. And then on top of all those 2x4s, plywood is put down, and that plywood is the decking. And then on top of the plywood, you know, we put on, you know, the tar paper and in the roof. In this case, there's a TPO roof on top of the decking. But basically, you know, both the deck and the rafter are both made out of wood. But the rafter's like 6 or 8 inches deep and 2 inches wide, and the plywood is like, I don't know, like a 1/2 inch thick. And so you can attach to the rafter, but it's going to be very, 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 very weak, because what makes a strong attachment between an anchor and you know, and the structure that it's attached to is the depth of embedment of the screw. And these are all the kinds of things that we show on our structural plans when we submit for a permit. And so it depends on the diameter of the bolt. It depends on the type of material of the bolt. It depends on the medium that it's being attached to. For example, are we attaching to wood? Then we want to use lag bolts. Are we attaching to concrete? Then we want to use Tapcons. And so we can show, how many pounds of uplift we're going to get in an axial pull depending on the depth of embedment. And so if you're in plywood, you only have half of an inch of embedment. But if you're in a wooden rafter, then you can easily have, 2, 3, 4, 4.5 inches embedded. And that's where you really get that pull strength. So it's critical to find the rafters. And so, I can grab this panel and I can give it a shake. Like, this thing is really on there well. So I showed what the end clamps were. An end clamp is the clamp that connects the end of a panel to a rail. This is a really cool end clamp because it's a hidden end clamp. Looking from the top, you can't see it, but it is in there, right? So the way that it attaches the panel to the rail is it grabs onto the flange of the panel frame. And then these guys, these are mid clamps. So a mid clamp has two shelves and it grips onto a panel. It grips onto two panels from either side. So most of the clamps that we're going to see are mid clamps. And those are all the clamps that go in between the panels. And then the end clamps are aptly named end clamps.
Can you show us, you were talking about the electrical connection that needs to happen for it to ground properly. Where does that happen? Does that happen where is that on each panel that there's a grounding connection being made?
Yeah, it's a great question. So basically the code requires every piece of metal to be grounded. And let's talk about what grounding means. The least amount of resistance for an electrical circuit that is grounded is to go directly to the ground. And when we say the ground, we don't mean some kind of metaphor. We mean literally the ground. And so, they say this hypothetically, if you could jump and grab wires, like the power wires, and you'd be floating in air, you'll be fine, even though you're touching high voltage wires, because it doesn't want to travel through you to go anywhere. The current is going to continue to travel on the wires. But if you jumped and grabbed the wires and, you kind of drooped down and your feet hit the ground, then you get fried because you would be the pathway between the current carrying conductors and the ground, and it would travel through you to get to the ground. So current always wants to go to the ground. We want to make sure that any metallic components are grounded. Otherwise, they can remain charged. So imagine like your metal electrical boxes, like that one right there. If there was a wire that became loose and touched that metal box, that box could be charged. And then you go to work on the box, not suspecting anything, and you touch that box, and because it's metal, you could feel a shock. So every single piece of metal, including the boxes that contain the breakers, has to be grounded, meaning it has to have a safe path to the ground. Now, earlier technology in grounding on solar components had special grounding clamps. They called them weebs. It was like a little thing with serrated teeth. They had grounding braids that you used to go from rail to rail. And basically, because of the new, technology, because of a new standard with UL, Underwriters Laboratory, they created a standard known as 2703. And that standard means that you don't need extra devices to ground all the metallic components. The components that you're using anyway, and specifically, I'm talking about the rail, the end clamps, the mid clamps, the standoff, okay, the standoff clamp, the channel nut, the thing that connects that to that, and even something called the splice bar, which is the thing that you would connect two rails so that they can continue, continuously. All of those are equipped with something that bonds them electrically. So let me take a step back. See, even though this is metal, there's an epoxy coating. There's a clear epoxy coating on this rail. And the reason is to make that rail corrosive resistant. Because incidentally, what is a good conductor of electricity also is subject to corrosion. So we want to use these rails because of their structural properties, because they can, really support the strength of of a solar system very well. But in addition, it's incidentally also, you know, a metallic thing, and that's subject to corrosion. So these things in the factory are coated with epoxy coatings, and you can see this has been here for 3.5 years. There's not a drop of rust. You know, it looks pristine. But because it's coated with that clear epoxy coating, that means that when you put the two metal pieces together, they might not conduct electricity, which we actually want them to do for the point of attaching them to the ground. If we could not bond all the metallic components so that they're electrically conductive, we would have to individually ground every single piece of metal all the way to have its own path to the ground. But because of standard 2703, these clamps in them right here, okay, this mid clamp, what you don't see is between the clamp and the panel frame, which, by the way, the panel frame also epoxy coated to prevent corrosion, there is a little sharp serrated tooth right in there, right under that. And when we tighten down the clamp, it's going to pierce that epoxy coating on the panel frame, and it's going to create a bonding. It's going to create a metal-to-metal connection, which makes this grounded. And so as long as the hardware, as long as the clamps can pierce that epoxy coating every time we attach one thing to the other, we only need to ground one point, and only have one point with a ground wire going all the way to the ground. And that's because all the other metallic components are electrically bonded to it. So we're going to go under here, and I'm going to show that to you guys. See if I can find my ground wire. Here it is. So this right here is bare copper. This is bare copper wire. And so what I'm doing with this is, Dane, can you see that? Is that coming out clear?
Yep.
Right here is called a grounding clamp. And what it's doing is it's grabbing the ground wire in the screw there. Bear with me just a moment. Yep, and it's definitely still attached to it. And what it's doing after it grounds it is it attaches the ground to the rail. And so this ground wire is going to continue all the way until it gets into that junction box. And then it goes from that junction box all the way down to the ground. It's going to connect to the inverter. And then the inverter connects its ground wire to the home's existing grounding system. And so everything that's up here is grounded. And so you can see that this is grounding it right here. And that means that everything that's metallic that's touching this, which is the whole row of panels, is going to be grounded. And then I have that same ground wire traveling over to the next row, and then it grabs it here as well. Because each row of solar panels is like its own independent metallic system, right? So if you look here, we have 3 rows of solar panels, and there's nothing attaching, you know, metal to metal, the first row to the second row to the third row, except for that ground wire. So that ground wire is grabbing one rail right here. It's grabbing one rail right here, one rail right here, one in this little system of 2 panels, and then it's traveling to the junction box, and it's traveling all the way to the ground. And it's traveling to the ground because it's tapping into the home's existing grounding system. So because I have snap and rack with that 2703 standard, I just have to hit the ground at one point of a row of panels, and thereafter, every panel frame, every rail, every clamp, every splice bar, every piece is grounded because of using this hardware.
I never knew that. I think that's fascinating. It's another reason why, we talk about like uninstall, reinstall. Like if people ever had to do something to their roof and take the panels off and on, like what happens with the places where it's pierced the epoxy? Like, is there any concerns related to the ability to avoid rust while also having that electrical contact?
Well, so if I took off this mid clamp right now,
Mm-hmm.
you would see like a little pinhole in that epoxy coating, just so that the serrated tooth in that uh mid clamp was able to drive through the panel frame's epoxy coating. I don't think that there's really a significant issue with corrosion. The other thing is that, you know, there's an impression left in the panel frame where the clamp was. And so I would say, if you hire someone to do an uninstall reinstall, if they know what they're doing, they'll line up the panels so that the clamps go back to exactly where they were.
Right.
And that way you don't have an exposed, epoxy penetrated, point on the panel frame.
Yeah, that's really cool. I mean, I've always heard about how important each connection, like you said, the weakest link in the chain for uplift, but also thinking about each link in the chain for grounding the panels so that they're safe.
It only takes one thing to fail for an entire thing to fail.
Yeah.
Because components, even individual components, are systems of components. So arguably, say that the entire solar array is a system composed of discrete units of solar panels and clamps and rails and power optimizers and inverter, which is true. But every one of those components individually is also a collection of components. So the individual panel, the individual module, is a metal frame, is a tempered glass cover, is a monocrystalline photovoltaic cell, is the white polymer backsheet on the panel. It is the junction box. It's all of those components, and any one of those components could fail, and rendering the whole product non-usable. So it's very important to pick the best products that can be picked, and the best solar company that's available to install them, because there's a lot that has to be considered when installing a solar system.
And it seems like it would be difficult to inspect. Like, even if you passed inspection, like it feels like it'd be really difficult to evaluate each of these components at the level to which something could go wrong.
Absolutely. There's a lot to that. I mean, we've been at this now for almost 7 years, and we feel like we've played a very strong role in educating the structural plan reviewers, the electrical plan reviewers, and being educated by them. But being in Florida, we work with several hundred building departments. I want to say that there's 70 building departments just in Dade County and Broward County alone. And so everybody's got their own unique idiosyncrasies. Everybody has their own unique, a couple of key points that they gravitate towards. And so as we've done more and more, systems that we've permitted and inspected more and more building departments, we get to hear the concerns at every single building department. And basically every time we do, we learn and we add those things to our bag of tricks that we make sure that we do. And I think that's one of the things that makes Goldin Solar such a good contractor, that we've done work in so many different places. And there's a lot of thought and consideration that goes into everything that we do.
How is quality control? Because I know that Goldin doesn't sub out any part of the installation process. Like, how does that play a role in quality control and the ability to like learn and iterate and build on the accuracy and the execution of installing solar systems over time?
It's a great question. So one of the things that we're really proud to say is we don't sub anything out at all. So Goldin Solar internally has a solar license, an electrical license, and a roofing license. And so anything that's done is going to be done by a W-2 employee of Goldin Solar. The reason that that's so important is because Goldin Solar has a very particular, very unique way of doing things. And it's just best practices that we've learned over 7 years of installing, around 1,100 systems. And so when it's our own employees that are doing it, we know that particular employee has installed hundreds of systems, and we know what they're worth, and we know that the quality of the installation is going to get done exactly the way that we want it done. that's not a given. Hiring another company, most other companies probably sub out the labor, and so it becomes sort of like luck of the draw. And I would say that solar is one of those things you definitely don't want to take chances on, because when the system's done right, I'll let the video here kind of speak for itself. It's the cell lines are aligned, the structural components are aligned, the waterproofing is done immaculately well. Solar is a beautiful thing when it's done right, but in the wrong hands, there's a lot that could go wrong. Things with waterproofing, things with roofing, things with grounding, electrical things with the wires dangling too much. We can see all the wires up here are totally concealed. And that's because we take a lot of pride in the workmanship. So we make sure that all of our wires are tied up really nicely. Some companies just let the wires dangle, and it works, right? Until a squirrel chews through a wire. So just one more example of the many, many, many things that we're always thinking about as we install.
I spent some time on a roof with one of the installation crews from Goldin in Orlando, and we were talking about wire management and how the roof gets hot. That's the part of a roof that you probably don't want things to touch if they don't need to. Is there more wear and tear on the components if they're touching the roof, like if the wires are dangling?
Well, so the wires that are used inter module connections, in other words, between the panels, that's known as PV wire. And so it's basically, the copper itself is the regular copper, but the thing that makes PV wire is actually the insulator around the wire. And so PV wire insulator is like extra, extra, extra thick, and it's made for UV radiation and high temperature and humidity. So that's PV wire, and that's why we can see that there is some wire, a little bit of wire dangling between panels, because obviously we can't have it in tiny little bits of conduit, right? So this wire, for example, is PV wire. Let's see if I can find it where it says it on the wire itself.
It still looks like it's far from touching the roof, though.
Yeah, exactly. I mean, there's multiple layers to just how much you care about things being perfect. I mean, in our case, I think that if the wires touch the roof, they'd probably be fine because they're really designed for high temperature. But that being said, if we can keep it from touching the roof, even better. The reason that I've always had in mind on why we want to make sure the wires don't touch the roof is because you could have squirrels, you could have critters, going under solar panels, and they like to chew things. That's what animals do. So, if all the wires are tucked away really nicely, just zip tied really nicely, they're much, much, much less likely to get gnawed on. And we've never, knock on wood, we've never been called for a complaint of that type.
What about like my parents right now are in their second year with their solar system, and they're wondering about cleaning. Now I can see that it could be difficult to access a panel like in the middle of the array there or something like that. If say if a panel needs to get replaced, or if you just want to clean stuff, what do you do to clean them? Can you talk about that? And then if you needed to change out a panel in the middle, how do you access stuff to be able to address issues?
So yeah, it's a good question. I mean, it really depends on the array itself. So this is my array, and I've got 3 rows of 13 plus 2 right here. And so let's say that I had to replace one like at the very, very middle, like right in the center. I'd probably have to lift up 2 panels. So probably what I would do is go out to, like, if it was that panel right there, I'd go out to there, and then I would take this one out so that I could access that one, and then I would work on it. So that's basically what we would do, right? We would typically just kind of clear a path to get up to the panel that's the one that we have to work on.
Got it. That makes sense. What about cleaning? Like, it doesn't look like you have, trees or anything, but I'm sure like if they get pollen or, what kind of cleaning is involved? It looks hot there.
It totally depends on what you're working with, which, like you said, it's how close are you to trees? How much, gunk do you have building up on the panels? I was up here 2 weeks ago, and the panels were really dusty. And I remember thinking to myself, I think I should come up to the roof and get, a bucket and sponges and start, hosing them down the way, you know, the former mayor of Miami, Phil Stoddard, had showed us at one time a couple of years back. So I thought, okay, cool, I'm gonna do that. And then what happened is, this past week it rained like crazy, like it rained volumes of water, and now I'm up here on the panels, and like they're really clean. They're really clean. So I don't really think that I need to I don't think I need to wash them anymore.
That's great.
See? Hardly any dust. I mean, I might still benefit from doing that, but it's cool because we use Solar Edge, so we have the tools to have panel level monitoring, and so we'll be able to see that just based on the display of Solar Edge. The panel level display. Are the panels producing enough current? Are the panels super dusty? Did they get filthy? We can see everything that we need to do.
Yeah. I think you showed that for just a second when you were looking under the panel, but there's actually a module under each panel that helps you understand how that panel is performing. Can you show that again?
Yeah. So this right here is a Solar Edge DC power optimizer. And so, not to be confused with the junction box. So the junction box comes attached to the panel. This is part of the panel. Now, traditional solar installations would take the wires coming off the junction box, which you can see this is a positive and this is a negative, and it would connect those in an electrical series. Okay, so you would be connecting positive to negative, positive to negative, positive to negative as you go from panel to panel. That's how things used to be done. And then you would take the string of panels and you would connect them to the inverter. And that's called, basically a series of modules, and that's a string line inverter. In that model, if one panel is shaded, the whole thing gets knocked off. It's, again, similar to a chain is as strong as the weakest link because it's in series. And it is similar to a light bulb going bad on a Christmas lights that are in series. The whole thing goes bad, and you have to start changing one by one by one until you find the bad one, which can be probably very, very, very tedious. So, enter Solar Edge, which is, by far the most efficient, by far the most advanced inverter on the market. They said, let's make the panels smart panels. Let's take an analog device that all a panel naturally does is just changes sunlight to DC power, and they said, let's make it a smart panel. So it's not an inverter, okay? It's not a microinverter. It's still DC in, DC out. But now, instead of connecting panels in a series, we're connecting the two wires on the panel to two wires on the DC optimizer, and then we're taking the positive and negatives on the DC optimizer, and we're stringing these guys together. So now, instead of a string of panels, we have a string of optimized panels where every single panel, see going down here, you can see every single panel has a DC power optimizer. And so what that means, that every panel has its own optimizer, is that number one, if one panel is shaded, the rest continue to perform at their own peak performance characteristics because it's not in a series. It doesn't have that limitation of being as strong as weakest link. And you have the ability to track, to actually physically monitor the performance of every panel individually. And so if we had a tree like right here and it was growing and it started to shade on just like these three panels, we would see that in the monitoring. And we would see, and it's color coded and it tells you the watts, and you can look at it, the kilowatt hours over different timelines. So you can look at it daily, weekly, monthly, lifetime, and we can say, hey, is that tree really significant, or is it not so significant, and maybe I don't need to trim it, or is it really bad? Is it really affecting my solar system, and I should really trim that tree because I'm losing a lot of power from it. So we actually get to see the answers to those questions.
Got it. What about if your roof wasn't TPO like that? Like, how would it work if it was on a shingle roof? You talked about an L bracket before, or the two things that go into the roof, but what, like clay tile, how does that work?
So if it's a clay tile roof, we're going to use a standoff, which is like a metal bracket. Actually, it's the same standoffs as these. They're just going to be shorter. But we're going to actually use a grinder, and we're going to grind a notch out of the tile, and we're going to put the bracket through the tile, sitting flush on the roof. And then we're going to flash it under the tile. We're going to waterproof it under the tile, and then we're going to use what's called topside flashing, which is like a aluminum flashing with a 1-inch diameter kind of sleeve on the top that the standoff pokes through, and then we're going to use these same rubber gaskets to seal up the standoff going through the flashing, and then we're going to shape because it's flashing. Think about think about something similar to tinfoil, but much thicker. But it's shapeable. You can shape it to the tile, and then we tuck it under the row of tiles above. So tiles are definitely really tedious. It's a lot of work, but we've developed some really good means and methods on how we waterproof tiles.
And then for just like a regular asphalt shingle roof, what does that look like?
So something very similar. We don't actually have to grind out of the shingle the way we grind out of the tile, but we're gonna have the bracket sitting on the shingle. We're gonna penetrate the shingle with 2 lags, and then there's gonna be topside flashing that basically covers the lag bolts and then tucks under the shingle above, so it then functions as a new shingle because the actual shingle underneath was compromised. And so water just cascades from the shingle above to the flashing, which goes on top of the penetrations.
So the flashing goes over the penetration and under the next shingle above it. So
That's exactly.
Gotcha.
Yep. Gotcha. So different types of roofs warrant different means and methods, but we're very proud to say we've installed solar on just about every type of roof that exists, and we're very comfortable. We're very confident with our way of doing things. We think that we do a really good job.
Yeah, I just spoke with a customer who is a friend of mine that got solar with Goldin, and he had a question about what the best type of roof was, and he got a standing seam metal roof. Yep. And he it was a bigger investment for him as he wanted to re-roof, but he went, he talked with you and he went with it, and he decided to go standing seam, and that's worked great. Can you talk about why standing seam is so special and why people might want to consider going with standing seam?
While I do that, I'm just going to point the camera at a neighbor here that has a standing seam metal roof. Is that coming out?
Yeah, I can see it roughly. Yeah, I can pull up a picture here on my side too.
So a standing seam metal roof is a roof that's made out of metal panels that are fastened to each other by basically folding over where they lap. And when you fold over the lap of the 2 metal panels, that creates a standing seam. So the seam itself is the fold over of 2 panel that lap over each other. So what's so cool there is that we then place the panels right on top of the standing seams. We actually put them in landscape orientation instead of portrait, so that we're maximizing the number of intersections between the seam and the long dimension of the panel frame. And so we fasten the panel to the seam itself, so we don't have to penetrate the roof. And so a couple of advantages. We're not penetrating the roof. We're not even penetrating the seam. All it's doing is it's like an indent screw. It's like a set screw. So it's just indenting the seam. And so to have a complete solar installation with 0 penetrations is a really cool thing to be able to say. And then the other thing is that it's the lowest profile installation you can possibly get, because we have the panels straight up sitting on the seam itself. And what we're doing is we're using the seams like rails. And so it's very clean looking because the panels aren't, way over the roof itself. They're sitting right on it. And then the clamps are just biting onto the seam and clamping the panel right to it.
Yeah, absolutely. Gotcha. Yeah, he was very happy about it. And so you could get the tax credit for the roof too, right? If you were needing to do a new roof for solar, Goldin has a roofing license, right?
We do have a roofing license. We'd be happy to put it on the same contract. And, I think that there's just probably still some gray area because the way that the tax credit's written is that the tax credit is eligible to your solar installation and all the costs associated with it. And, arguably, if you did a roof at the same time as you did the solar installation, you did it in order to support the solar installation. So we know a lot of people are basically, claiming the tax credit against all of the scope. And we're licensed roofers, so we can do it all on one contract to make that, very clear, very clear point that it's solar and roof all happening because of the solar installation.
Got it. Got it. Well, it looks like it's scorching out there, so maybe we'll let you come back down off the roof unless there's anything else you have to show us.
No, I think that's about it for the roof.
Okay, cool. I'm gonna jump back over to sharing some information about Powerwall
Yep.
while you jump down, and then we can finish up with some more information when you're back in the air conditioning.
Sounds great.
Okay, cool. I'm gonna share my screen here again. So that was great. That was a really deep dive into the realities of mounting your panels on your roof. I just wanted to get back here to answering the question about how many power walls somebody may need. So we talked about you need to consider how much energy you need, and you need to consider how many amps you're going to want to be drawing from your backup, and essentially how many appliances you'll want to be using at the same time. So we've made this graphic here, which we'd be happy to send to you, and this can help you understand the right number of power walls for you to pick as you're looking to get home battery backup. And essentially, all you need to really consider is how much you typically use on a daily basis. You want to divide that by 2, because you're going to be drawing straight from your solar system for arguably half the day when the sun is out. And then, the other half of the day when the sun is not out, you're going to be drawing from your battery. So you're going to look at half of your daily energy consumption, and each power wall contains 13.5 kilowatt hours, which means that you've got 13.5 kilowatt hours of storage that you're able to draw from. So whatever half your daily consumption is divided by 13.5, that's one factor for how many power walls you would need. And then the other factor is just looking at the largest breaker in your distribution panel, considering how many appliances you would like to run at the same time, and dividing that by 30, which is the number of amps of a single power wall. That will also give you one of the 2 considerations that you need to look at. And then just here at the bottom of the graphic, as it says, you're going to choose the higher of the 2 to know how many power walls you'll need to back up your home. So Daren has 3 power walls on his home, and I'm going to let him tell a cool story about when he accidentally left his power to his home off, that he was able to just have business as usual, running his home from the sun coming up each day and charging his power walls. But battery backup is a reality now, and compared to a generator, it has many advantages. We talked about not needing to have fuel for it. There's also zero maintenance involved with the battery, which if you know anything that is a combustion engine, there are frequently things that go wrong. I know that when I was growing up, my dad had a generator, and we would only pull it out when we needed it during a hurricane. And I just kind of grew up with the impression that it was one of those things in the garage that just never worked. And so if we had solar and a battery, we probably would have had power a lot more often during an outage when I was growing up. So just some things to consider as you're trying to figure out how to keep your family safe during an outage. As I mentioned before, Goldin Solar is a certified installer for Tesla. And so we'd be happy to help you get ready for hurricane season if you're interested in Powerwall. Daren, are you back into the air conditioning yet?
Though I don't look like it, I am, because I'm drenched in sweat.
It sounds like we may be getting some feedback. That's great. That's great. Thanks.
Just shut off my phone.
Got it. Yeah, thanks for taking one for the team and going out in the weather while we all sat in the air conditioning probably.
Yeah, no, enjoy it. I'm proud to be able to give people air conditioning with our beautiful solar systems and our wonderful whole home battery backup. So, if there's one thing that we've learned, it's that Floridians consider their air conditioner to be a critical load. Nobody wants to stay home without an air conditioner. And so, it took us having the ability to offer Tesla Powerwalls to be able to give people whole home backup. And that's when we really started to feel comfortable about selling, high volume of batteries because, to be able to tell people, yes, you can stay home during an outage. That's a very nice prospect.
Yeah, especially during a pandemic.
Yeah, definitely.
Yeah, absolutely. We were just talking about Powerwall while you're coming down, and I kind of brought up, but I was going to let you tell the story about when you accidentally left your main distribution panel off from the grid, and so you were drawing completely from your power walls for 3 days or something like that.
Yeah, totally. So it's like this. I set up power walls in my house, and I love showing it to potential customers. So I'll invite customers to my house, and what we'll do is we'll get set up right at the window here, where they can look through the window and look at the lamp. And I tell them, listen for the click. And what I'm doing is I'm shutting off the main breaker with FPL, thereby simulating a power outage. And as soon as I shut off the main breaker, for all intents and purposes, the house, the electrical system, sees it as though there's a power outage. And I show this to customers, and then you see like a little millisecond flicker in the lights, and that's it. You've moved from the grid power to being powered by power walls. And so I'll show this to customers. And one day I did this demonstration, and then I continued talking to the person for a little bit, and then they left. And then I got distracted, and I forgot that I turned off the main breaker. And then my girlfriend and I started making dinner. And then the next thing you know, like 3 days go by. And I never turned the main breaker on. I just forgot. And so then I had gone back into the portal, like online, to show somebody what the user interface looks like. And then I noticed, like, wait a minute, I've been feeding off my batteries for 3 days. And they were, I don't know, like 70%. And, to me, it was just really, really cool of the fact that it's so seamless that you can go days and forget that you're even on a backup system. And in theory, I think those days could have been weeks and could have been months. And I just would have totally not even remembered that I was on a backup system.
Why don't you just leave it? A lot of times people will ask me, well, instead of using the grid, can I just use my batteries all the time to be self-sufficient?
Right. So great question. The answer is, in theory, yes, you can. And in fact, I can think of at least one customer that shows that mode on their Tesla app. So I'm rebooting my phone, and I'll show I'll show our viewers what that app looks like, what that interface looks like. So you can choose 2 different settings on the Tesla app. One of those settings is self-powered, and then one of those settings is backup only. And so I have it in backup only, which means that as long as the grid is live, my system functions like a regular grid-tied system. Batteries are fully charged, fully topped off, ready to kick in if they're needed when the grid goes down. But as long as the grid is functioning, my house is buying and selling energy with the grid through that bidirectional net meter as if I didn't even have batteries. Self-powered means that you want to use your battery as the primary, and then the grid is the secondary. And what that means is that, let's say it's nighttime and you don't have any solar power, you're going to pull power from the batteries to power the house. And you're going to do that first. And then it's daytime and you're overproducing. You're going to take your excess power and you're going to send them back to the batteries before you send it back to the grid. Now, the grid's still there. So if the batteries are full and you still have overproduction, you can send the balance back to the grid. Or if it's nighttime and you already drained out the batteries, you can take the rest from the grid. But it's just an order of operations. It's what happens first. Now, I generally don't recommend anybody to go into self-powered mode in Florida. In Florida, I recommend to keep that, the batteries on backup mode. And the reason that I say that is that the batteries are 90% round trip efficient. So when we say round trip, we mean when you charge the battery and then discharge the battery. Round trip. And that means that you lose 10% when you do that. Now, the equivalent to that with grid interaction is when you overproduce and you sent your extra 100 kilowatt hours to the grid, and then it's nighttime and you pulled your 100 kilowatt hours back to the grid. There are essentially no losses there, because you're not converting electrical energy into chemical energy and then back from chemical energy into electrical energy. There's way less complicated things happening. So here's my app, my Powerwall app, and I've got 3 Powerwalls there. 90.
Can you hold it just a little bit further away so it'll focus? Yeah.
How's that?
Nice. That's great. Perfect.
So they're 97% efficient. And then I can go into customize. And in customize, I have multiple functions here. So the first one is backup only, which has the circle checked. So that's what I'm in. And then the second one is self-powered, which is not checked. But it's as easy as just going from one to the other. And you can.
What is Stormwatch? I saw that down there at the bottom.
Yeah, so Stormwatch is it's checked on, and it is Powerwall detects incoming storms and fully charges to provide backup power after the storm system will return to its previous settings. And so that means that you might be in self-powered, and that means that at any given moment you could be at 40%, you could be at 80%, depending on how much you're using and how much you're producing. But in Stormwatch, you would override that and just get the power walls fully charged when there's a higher likelihood of a power outage, to make sure that if there's a power outage, you start with the maximum state of charge in your batteries.
Just another piece of homes which are becoming increasingly smarter. It seems like there's a lot of ability to do cool stuff with that. So
that's it. It's it never occurred to me how much I needed these things until I had them. And I always use the analogy, this must be what it was like to get seatbelts installed in your car. So back in, I don't know, the 40s or 50s, when seatbelts just became a thing, before you had a seatbelt, you would have never dreamed that you actually need this thing. Like, I don't know, I don't need this. But now you'd never go in your car and not buckle your seatbelt in a million years.
Right,
and that's generally how I feel about what it's like to have whole home battery backup. Because before I had it, I said, all right, the hurricane is going to come maybe once in 5 years. But now that I have it, the fact that a hurricane can come in and knock down the grid, and in milliseconds like that, the whole house is powered, and it's indefinite days of autonomy, so long as I work within my solar production, that to me is amazing.
Peace of mind, yeah.
This house now feels like an electrical bunker. I feel ready to take on a hurricane, and we're very excited to be bringing this to our customers.
Is there another certain new product that we can talk about on here that you would like to introduce and show? Is that doable?
Yeah, I think that's doable. All right, so just to give a little background, there's two different actual devices that go into a Powerwall system. Those two devices are the actual Powerwall, which the Powerwall itself is a battery and a coolant and a inverter and a rectifier. So it delivers AC, it receives AC power, and the reason is it has an inverter built into it. And because of that mechanism, the system still has to have its own way to safely disconnect from the grid, right? So Tesla created a second component, which is called a backup gateway, and that is the device that safely disconnects from the grid. And so I've had backup gateway installed now on my house. It works, it's amazing. Everything's good about it, but Tesla just came out with a backup gateway version 2. They sent one to me, and I'm gonna show it off to you guys.
So real quick, just for those who may be confused about what he's talking about, you need something that's going to be able to disconnect you from the grid in the event of an outage, because typically with just solar panels, if the grid goes down, your home will not be able to use the power that you create for several reasons, one of which may be not wanting to put people in danger who are working on the power lines. So when you get a Tesla Powerwall, you're going to get this backup gateway, which enables your house to disconnect from the grid so that you're able to power your home with the batteries. And so that's what this is, the upgraded version of that.
Yeah, so this is the Tesla Backup Gateway 2, and whoever's seen the Backup Gateway version 1 knows that it looks like a regular electrical box. It's a regular kind of grayish electrical box. It's got antennas on the top for its communication, because of course, this is also kind of like the brains of the system, similar to the inverter. This is where we can monitor the consumption, the production, the power flow, what's going where. We get to monitor all that. But the original backup gateway looks like a regular electrical box. This is the backup gateway version 2. So, the biggest, most obvious update is the aesthetics. And this is absolutely just a stunning box, for lack of a better term. But that's what I love about Tesla so much. they'll take even the most kind of mundane, sort of functional products, and they'll make them beautiful. You know, obviously you want to make your car beautiful, right? Obviously beauty is a very important thing for cars, but whoever thought beauty is as an important thing for electrical boxes? Well, apparently Tesla does, because Tesla cares about making everything that they touch stunning. And
next,
so,
it's going to be custom branded wiring insulation.
Exactly. Custom branded wire nuts.
Yeah.
You know, custom branded crimpers. But anyway, the aesthetic is basically designed to look like a Powerwall. So the actual Powerwall is a powder coated white, you know, metal cover. This is a little different in that it's actually tempered glass. All right, so we'll try to show it here from the side. Is that side profile coming out?
Yeah, I can kind of see that.
It looks like it's about a 1/4 inch thick tempered glass. And so that gives it this nice, you know, shiny finish. And it's just a beautiful product. So let's talk about the improvements. You've got the aesthetics, you know, that's probably the most obvious. On the inside, we have this that we don't have on the original backup gateway. This is 6 spaces for breakers. So you can actually put breakers here. And those breakers can be loads, they can be power walls, or they can be an inverter. So right now, my current configuration of my power walls is that I have one box that we call the renewable energy sub panel. And in there, I terminate my 3 power walls and my inverter. But going forward, because the original backup gateway doesn't have breaker spaces, so I have to connect all of those things, and then I take it to the backup gateway. But now, because this backup gateway has breaker spaces, I can terminate the breakers for the power walls and the inverter and any loads directly on this bus bar.
So just to make that a little more clear, because I'm a little fuzzy, but it sounds like what you're saying is that you would have to have a sub panel before you have to install a separate device to be able to like sum up all of the things that would go into the backup gateway. And now you're able to just do that directly in the backup gateway instead of having to have a sub panel. Is that right?
That's exactly right. That's exactly right. Now the caveat is that they're giving you 6 breakers worth.
Mm-hmm.
So in my case, I might not be able to make sense of it because I've got 3 2-pole 30 amp breakers for my 3 power walls and another 2-pole 60 amp breaker for my inverter. So that's a total of 8 breaker spaces. I've got 6. But for other customers that have 1 inverter and 2 power walls, you've got 1 inverter, 1 power wall, and 1 power wall.
Got it.
Yeah.
Got it.
So in most cases, this will be enough to eliminate the breaker panel, the sub panel.
I see.
But in some cases, in cases of like larger systems, it won't. But that's okay. By the way, you don't necessarily have to use this for your inverter or your power walls. You could also use this for loads. So imagine we have a customer that has a main or his distribution panel out in the garage, and that's the main panel that's going to be backed up. Then there's another small pool panel like around the side of the house with a couple of small breakers for like a pool pump and maybe some pool lighting. So we'd be able to have the pass-through lugs on this panel backing up the entire main distribution panel for the house, but land a couple of smaller breakers here from that pool panel. So it's another use for this. We can actually back up loads that otherwise would be difficult to have a place for them to connect to. So this saves a lot of headache. Other than that, Tesla has improved the monitoring devices on this, which are their own clamps for their own power production monitoring. So they're monitoring production and consumption. And I've understood that the efficiency is now much higher. It's much more efficient. And then the other thing about this is that there's also a set of outputs here for loads specifically to not be backed up. And it's very intuitive. You might say, why do I want loads not to be backed up? I want to back up as much as possible. Well, the answer is one of your loads might be your electric pool heater.
Mm-hmm.
Well, that takes up a lot of energy. You know, you probably don't want to heat up your swimming pool in an outage. You probably want to conserve your power for, you know, your air conditioner needs and your lighting for stuff that's really actually necessary.
Right.
Besides, in hurricane season, that's the summertime. Hurricanes by nature happen when the oceans are hot. And so that's when it's hot out. I'm thinking the last thing you probably want to use your backup power to do is heat up a swimming pool after a hurricane that resulted from hot water. So, you know, that just doesn't make sense. And so, you want to figure out a way to to power that pool heater normally, but not power it in an outage. This has now solved that problem. So there's now a set of electrical lugs that allows you to connect something that can be powered in normal operation, but not powered in an outage.
How would you have to solve that now if you wanted to? You would just not have that go into your sub panel, or how would that work?
So I would specifically have to connect that upstream from the point that this is connected with. In other words, the backup gateway isolates from the grid, right? So I would have to connect whatever I want to isolate upstream from the backup gateway.
So you just turn your heater off? Is that what you're saying?
Well, yeah, that's one way to do it, is manually turn off, right? So that's always an option. You just go out and just shut off that breaker, but that's if it's on the backed up side. But you're asking me if you want to not even have to manually turn it off. You want to know that when you switch over to backup mode, that pool heater is not going to be on that circuit. So that's doable. You have to connect it upstream from this point of connection.
Gotcha.
Yeah.
Great. And that's not available yet, right? That's a special special preview from Tesla. Do you know when this will be available for people?
Yeah, so you know, I feel very fortunate that Tesla, you know, sent me an early one to try out, and I'm always happy to try things out before you know, before we go putting them out in the masses, just so that we can see how they work, and we can speak about it with experience. But these are now starting to be ordered by us.
Oh, great.
So they are, absolutely. So anybody that signs up today is going to have this you know, magnificent backup gateway, and you know, again, you line it up next to your power walls, and it, you know, it looks really nice because it's gonna have that same matching aesthetic.
Very cool. Yeah. Has Tesla solved all the other problems in the world, and now they're just like making everything look beautiful?
That sounds right. Yeah.
Very cool.
If you want, I can you know, do a little kind of walk right now to my existing setup and show what my existing system looks like.
Yeah, sure. Yeah. We're mobile now, so we've been up on the roof. Let's check out the back.
Sounds good. All right, I'm just loading up my phone because I'm just did a software update. So yeah, so we're gonna do a video that we want to, you know, share with the internet, because it's fun for us to have equipment that's really brand new. So yesterday we filmed a video just kind of introducing it, talking about what the backup gateway is, and then did a little bit of video showing my current system. We're going to do a time lapse of changing out backup gateway version 1 to backup gateway version 2, and then we're going to talk about some of the benefits.
Very cool.
Yeah.
Very cool. While we have a moment, I want to just introduce what we're going to be doing next week. You know, this is a weekly series for us of doing Fridays with Daren. Next week, we're going to be having a very special guest who is going to be teaching us about some of the results of, well, really last week. Let me back up. We talked about climate change in a historical perspective last week. And we talked about where the Earth has been in terms of temperature, carbon, sea level, and then we've talked about where we are right now, and the effects that humans have had on carbon dioxide in the atmosphere. And so next week we're going to be speaking with a hurricane scientist who is going to be jumping into some more of the effects and some of the realities of what our planet warming is contributing to storms. And so he's a researcher that publishes a lot of really cool data and collects data himself, like almost like as a citizen scientist. But he is someone that studies storm systems And to be honest, I really don't know what to expect as far as the data. Like that's one aspect of this that is so specialized that I really haven't gotten to speak with anybody that's kind of specialized in that niche of being a hurricane scientist. But it sounds like he has a lot of insights to share with us. And so if you're watching this now and you're interested in that dimension of what's happening with renewable energy in our planet, please tune in next week to listen to Brian with us. He's going to be definitely diving into that. And then the other thing that I wanted to share real quick is a lot of the content that we're talking about has been translated into blog articles on our Goldin Solar blog. Elliot is one of our staff here who has been crafting a lot of really quality content about everything from renewable energy to climate change, and has compiled a lot of really useful information over on the blog section of our website. So if you want to learn some more and be able to search through the topics that we've covered and have some articles that you can reference, you can go to goldinsolar.com and you can go to our blog section, and it's just gotten redone. I think it's really beautiful, and there's some really great pictures and stuff in there as well. So I hope that you'll enjoy that and check out our blog section as well. Daren, anything you'd like to add? Are we ready to go out to yonder?
I'm still updating my apps because I just rebooted the whole software. So let's see, I'm at 230 out of 248. So I just need probably about 2 more minutes. Wanna
Got it.
chat about something, and then we'll do a tour of the system.
Yeah, for sure. I had something here that I wanted to share. Let me see if I can pull this up on my screen here. Cool. Do you recognize this?
Yes, I do. Yes, I do. Time traveling.
Yeah. So this is like the other side of the fence.
Right.
When I pulled this up, like this really gives me a sense of how much detail goes into the side of it that you don't see.
Yeah.
Can you tell us a little bit? This looks like the clamps on top of it. Like one thing we didn't touch on, I think this is like a layer of silicone that's laid down. Like it's all white, like super, like compared to your neighbor's roof there. What is that?
So my roof had an asphalt roof on it, like a regular hot mop asphalt roof, which, has a certain lifetime. It's sort of the default kind of flat roof. I decided that I never wanted to ever worry about my roof ever again. And so the first thing that I did is I changed out my asphalt roof to a TPO roof. So TPO is a thermoplastic. It's basically, something that's a little higher end. It's the kind of thing you see on commercial buildings. And you've got 2 layers of TPO overlapping each other. And then what they do is something called a heat weld, where they basically melt one layer on top of the adjacent layer. And as a heat weld. And so I finished the TPO roof, and I said, this is cool. And so the cones that we see here, that's the flashing, right? That's the thing that waterproofs the penetrations. So on the inside of the cone, we've got the bracket that it attaches to the rafter, and then we've got a 1-inch diameter cylindrical post coming up and through the cone. These cones, these types of flashing are custom made. So I get to specify to the manufacturer of these flashings the type of TPO, and we use the same one that the roof is made out of. We specify the width of the flange. So the flange is the flat part of the cone. Then we specify the bottom diameter, the top diameter, and the height. So basically everything about it. And they make them to our specifications. And then what we do after the bracket, so the bracket's sitting right onto the surface, right on the TPO. And then we fit the cone on top, and then we heat weld the flange onto the TPO. And so what that does is creates that waterproof seal. And so we've got the flange heat welded onto the TPO. We've got the stand coming up and through the top of the cone. And then we have the whole thing coated in silicone because why not?
Yeah, it looks pretty space age.
Yeah. So this whole thing was right before we put the rails on. And as you imagine, I was like really uptight to make sure that we don't puncture the coating with the sharp corners of the rail. I said, this thing is like super waterproof. I want to make sure we don't damage it. So I was really kind of meticulous when I supervised that. And so, yeah, on top of this, we put so we have the standoff clamps attached to the top of the standoffs. Then we put on the rails, then we put on the panels, optimizers, and go from there. But as far as I'm concerned, this was the hardest part, was getting that really perfect seal. So, hey, I got my phone live. I'm going to get this going. I'm going to step away from the computer to avoid feedback. Can you hear me?
Yes.
Perfect. All right. Can you change the camera over to me?
Yes.
Awesome. All right. So you can hear me, you can see me. So here we are outside. This is my Powerwall setup. So I've got a nice little side yard. So I've got battery 3, and just kind of moving along here, battery 2 and battery 1. Okay. So earlier we talked about the sub panel. That is this guy right here. So this is not a Tesla panel. This is a regular panel, and this is what we call the renewable energy sub panel. So again, I got battery 1, 2, and 3. I've got my inverter. This 20 amp breaker is just the electric gate. So I wanted to make sure that that was one of the loads that will be backed up, because it used to be on the meter main combo that would have not been backed up. And then I have the main for the entire thing. And then, so going across to here, I've got the inverter. And the inverter I've had for 3.5 years, right? This is the original inverter. And again, that's the advantage of having AC coupled batteries. I don't have to change out the existing equipment that's up here. And then this is backup gateway version 1. So I've just shown backup gateway version 2, the beautiful box with the nice white, cover that matches the power walls. But this is the original version, and you can see this is a Tesla device. So this also is from the Gigafactory, and you see there's no breaker spaces here. This is the backup gateway. This is the method that we safely disconnect from the grid. So you asked me earlier, what would I have had to do if I wanted to have loads that I made sure did not get backed up? And the answer is I would put them onto this bus bar, because this is my meter main combo. What happens is power comes in from the ground, goes through this side channel and into the meter on the top. That's FPL's power. Then it's metered, and then it goes into the main breaker. And then it basically charges the whole bus bar. And then out the bottom, it's going to go to the distribution panel that's inside the garage. And so what I do is I intercept that with the backup gateway. And so now the backup gateway can isolate anything that's here, while still making sure that we power the distribution panel inside the house. So I used to have that 20 amp breaker right there for the electric gate out in the front. And what happened is that was not getting backed up when I was in backup mode. So I just installed this small conduit, and I moved over that breaker into here, because anything that's in here is getting backed up in backup mode. And the reason that's getting backed up in backup mode is because it's terminated here with all the breakers of the Powerwall and the inverter. So in the same way that I moved something from here to here to make sure that it gets backed up, I could also move something from here or anywhere else to here to make sure that it does not get backed up. But now that's something that they added to Powerwall. The backup gateway version 2. So I have a log to make sure that things don't get backed up, or I can connect it on side of things that I do want to have backed up.
Got it. Very cool. Very nice back patio area there.
Absolutely. I appreciate it. I have to get the plants going on. If I show the place to potential customers, this is all new. We got to have a living wall to keep it fresh. And
I was gonna say, are you still gonna try to do edible living wall there along the side?
No. So we got these Jurassic looking things. Lilies, and then we got this cool flower, and so on and so forth. Yeah, the point is, I just want to have some living things here in the side yard, because Powerwalls is about backup power, but it's also about earth. It's about renewable energy. It's about being one with nature. So, yeah.
Very cool. Well, thanks for sharing that, Daren. Anything else that you want to cover in today's live stream here?
And I think we covered a lot of territory.
Yeah, we did covered a lot of ground for sure.
Cool. Yeah, I would just close with, dear viewers, check us out, buy our power walls. We want to keep you and your family